Typeahead or Autocomplete system. Um, Typeahead or Autocomplete system. It's very popular during interviews, and in reality, it's also super helpful for search services. So there are like different use cases for this system. We need to talk with the interviewer about what use case we're dealing with. For example, there could be use case for search service, right? Like Google, Bing, etc. Or it could be a text or IDE editor that you like it will autocomplete the variable name or the function name for you. Or it could be like for the for e-commerce website like Amazon, like when you search a product, right? Search a product, etc. So yeah, they're like widely used in a lot of like services, and for our design or for our design mock, we will focus on the search service. So the requirements here, we will start with functional requirements. It will help for the search service. So when user type something to search, we will call our backend autocomplete service to help the user to just autofill the word or the phrase. Yeah, so it's a search service. We will start with English, and let's just focus on the letters. And we will show the top 10 readouts. And based on the frequency of the words or the phrase, that's how we rank the top 10. So we'll start with like 3 to 5 bullet points for the requirements. So it will help with the search service. We'll start with English letters, top 10 readouts based on the frequency of the words. What else of the requirement? We need to like keep talking with the interviewer. For example, do you want to work on the personalization or not? Or we just like will not consider personalization yet. So the like common shared like search trends for all users. We can, if we have more time, we can briefly talk about maybe the user's search history, etc. But let's not cover that for now. So I have like 1, 2, 3, 4 requirements. Yeah, okay. Let's start with the non-functional requirements. Firstly, most importantly, is like definitely performance. Low latency. The latency. The P99 should be like around, let's say, 200 milliseconds. We do not want the user to feel the delay or the latency to avoid like the user experience, to avoid impacting user experience. The second non-functional requirement could be fault tolerant. What that means, for example, there may be some component in the system just error out or timeout, but we should still serve the user with the maybe not 100% accurate, the top 10, but maybe less frequent, but still we want to serve the user with the results. So yeah, here is mean like we should even serve the degree dated results. Oh. Even yeah, degree dated results. Next one will be scaling for sure. We are talking about maybe like 1 billion requests per day. Like Google maybe more than 1 billion, but let's start with like 1 billion requests per day. So it should be scalable. Let's start with these 3 requirements, non-functional requirements. Yeah, we can. It's only like 6 minutes right now. We are aiming to talk about the requirements for about 10 minutes. So let's briefly talk about more use case we want to cover. Search for the when user type search service. So we'll start with English letters. Top 10 results. We will start with we will work on the words and phrases, right? So it's not only the words. If only focus on the word, it'll be more simpler. But let's focus on both of them. No personalization should be shared across all users. There could be some. Okay, one more requirement. Do you want to cover real time? Hot trending words or phrases, like most likely this will be there will be some like offline batching jobs to deal with the frequency of the words. But do we want to cover real time? Yes, we can, but we can talk about that. Maybe a Lambda architecture here will make sense. Non-functional requirements: performance, low latency, yes. Fault tolerance, yes. Scaling, efficiency. So it should be quite, yeah. Actually, efficiency should be a goal of every system. About the cost, we serve the results. Also about how efficient of all the for the whole system. We will have some metrics on that. Okay, so now let's just start with the data estimation. Data storage estimation. So we are talking about 1 billion requests per day, and we will only focus on English letters for each chart. Let's say we can have like 1 byte per chart for English letters, and on average, let's say we have 6 charts per word or per search, right? So we have 1 billion requests per day, and we have on average the search word or phrase will be 6 charts, and for each chart it's 1 byte. That give us let's quickly do a math. So 1 billion then meg by gig, right? So it will be 6 gigabyte per day. That's the data storage. Let's say we keep 1 week in our data storage. That give us 2 per day times 7, 327, around 50 GB. Okay, that's like the data storage on average. Cool. Let's start with the high-level design. So for the high-level design, definitely there will be UI, and then we will have the backend service of the UI. In the between, there will be like load balancer. We didn't draw that. The UI will call the backend service. Backend service will call our autocomplete service. Autocomplete service. There will be a load balancer in between as well. And for our autocomplete service, it will call our distributed data store cache. Here we will use Redis to store the data. Okay, so we just call the Redis. That's the query flow. And then there are two main workflow here. One in the query, one in the injection. Oh, injection? No. Aggregation. Okay, let's say aggregation flow. What that mean is, so we will have the aggregator or aggregation service, and the backend. When the backend get a search phrase, it will, let's say we will use a message queue here. Message queue, it could be Kafka. And then our aggregator will consume that event. They're actually, yeah, let's start with this. Different ways actually. But so we will have that event, we will consume that event with aggregator. And the aggregator is actually a service consume the event. It will dump that event. Okay. So there are two parts for the aggregator. One part, there definitely, let's do more stuff. Here is a words filtering service. So we'll make sure for the inappropriate word, we'll filter them out. And for the filtering service, we may have a UI for that. So the user or the admin can add or remove the word. So the aggregator will do a very early, will do a filtering on the search string, and then it will dump the data to HDFS, a file system. So here, so from here, let's say consumer, just event consumer, then dump to the HDFS. So from here, there's a lambda structure. One is the on the very high level. This is the Spark streaming, real-time streaming job. Actually, streaming job should be here. Streaming job, and streaming job will just update our Redis. Streaming job will also call our filtering. It's shared. This is the real time. And then we have this batch job, ETL. Jobs load data from the HDFS and write to Cassandra table with here batch job. For the Cassandra table, we can quickly draw the table, so it's like aggregated. And then we will have another service called, oh, it's actually shared here. Redis. So we have a service here. We will we call the data structure is try. So it's try builder. So the try builder will load data from the Cassandra and build the try in the Redis. The real-time part the same, so streaming will stream the data to the try builder. Okay, so that's the very high-level design of our system. Now we spend around like 7 minutes on the high-level design. We want also talk about the API and data schema for this part. So the API here, we have mostly two parts. One is get the phrase based on the prefix, right? So it will be a list of the words or the phrases already ranked by the frequency. The other one is send the query to the backend. So here is the query string to the backend. So it will have the boolean like success or not. Very simple API. And for the data schema, so we need to talk about the data structure here for the try. We will have the try data structure, which is popularly used for this type of system. To draw that, we'll start with a root node. And then we will have, for example, let's say we want to type like dog and dad and darling. Yeah. So like, let's start with these 3 words. So then the root, we do not have any word for any chart for the root. But then because we start with D, so here we'll go to the D node. D. And then we will have the O and A, right? So A will be here, O will be here. So we'll have the A, O lowercase. And O. Did I do? Yeah. So here, on the requirements, let's try to limit it to O lowercase. In our system, we'll just keep that. So we have this DA, and will be a D. And we need to make sure this is the end of the word. So it'll be so we can have something to mark is at the end of the word. DOG, so we have G here. So same thing, it's the end of the word, so it's a word. We will have a R here is not the end of the word yet, and LING, right? So for example, let's say I will simplify just LING, and we'll say this is end of the word. Okay, so that's how a try will work. It will go to each node and will try to go deep of the node until it finds the word, and then keep going here. Okay, so since we need to rank the word or the phrases, so let's add something here, for example, for the that, right? So let's add the frequency for that. It could be, let's say 20. So like we have 20. We saw like the dad was searched by like 20 times. For dog, more popular, maybe 100. And for darling, 10. Okay, so when you type D on the UI, what do you get? So you will get the dog, right? Because it's 100. So you get dog, you get that, and you will get darling. That's it. That's you have. What you can get. So that's the try data structure. And to get that, we need to build the try, keep building the try. So here, one question. Okay. Before we jump into the detailed design, we also want to quickly talk about another data structure here in the Cassandra, right? For the HDFS, yeah. So for the HDFS, we just store because that's like the raw data, the raw search data. We can say the user, the word string, what we search, timestamp, when it was searched, right? User, by whom. For example, that was searched on this timestamp by this user. User A or user 1 or something. We'll have more records on that. The first column, we may not need that, so it's fine. So that's the HDFS. And then we'll have the aggregation jobs. So we will the ETL jobs. So we will load the data, the raw data. This is the raw data, and we will do aggregation, and we will write into the Cassandra table. So in our Cassandra table, it's a different format. It's quite similar to what we store in the try. So it will have firstly the string, either the words or the phrase, and then the frequency, because we already aggregated. So like that, here is like 20, and then here is the time. It's not a timestamp, it's the time interval. For example, the first hour of the day, for example, if we store hourly data and we want to aggregate based on every hour. That's the Cassandra table schema. And then in the Redis, right, in the try, we'll have this, okay, that 20, and we'll have the timestamp, the time interval, like for the first hour. Then we have the real-time streaming. So the question comes to, okay, let's jump into detailed design now. Detailed design. Firstly, real-time streaming. For each request, do we need to update the try tree? The answer is no, because that'll be like too often and like too much update, and may impact our read or our search performance, right? So to support that, even our streaming jobs, we will do like some processing window. So the no updates on each request, but on predefined window. For example, every 10 minutes. So every 10 minutes, we will aggregate the real-time data, and it will try to update the Redis. But that is the, for example, we have the first hour, and now it's the 10 minutes after the first hour. So we'll have a different record that the frequency may be 10, and then it's like the latest data, right? And then the we will also, like for the batch job may run like every hour. That will have more accurate data. So the batch job, when the batch job is done, it will update the Redis table with the more accurate data. And then we'll have the streaming job keep updating based on the previous batch readouts. That's like how a Lambda architect works. Let's quickly go through the requirements. Oh, okay. So for the detailed design, we can talk to the interviewer, like which part they are interested and which part we want to dive deep into. For example, if they are more interested into the autocomplete service, then we can talk more on autoscale, how to autoscale the autocomplete service. It's stateless because the results are in the Redis. We can have a local cache in each pod, but we need to refresh this cache like every, I don't know, 5 minutes or every 10 minutes. For the Redis, it's also auto-scalable. We will have a cluster, and we will have the primary, secondary Redis pod, or sorry, Redis node. And then we'll have the streaming come to the try builder. So the try builder is the service who will build the try, update the Redis. Okay, so what if a single, okay, we have like 50, right now for one, if we want to keep 1 week's data, we have like 50 gigabyte, right, for the Redis. A single pod may not be good, large enough to store the data, and we need to shard. Sometimes we need to shard the try tree, right? So okay, how to deal with that? So to shard the try tree, which means for A could be shard for D, this node could be a shard, and for another character, A could be in another shard. So they're like different shards. For the autocomplete or for the try builder, how do they know which shard they need to talk to? So here we will use we will have a discovery service. I'll add here. Okay, let me just add here. It's a discovery service. Everyone will talk to the discovery service first and found which shard they need to talk to, and then they will talk to that shard directly at the second step. And for the discovery service, normally we will have a zone keeper to store the mapping. Oh, Okay, yeah, you just know here. Let me see how can I move everything. Move up a little bit. Oh, that awesome. Okay, so this will be a zone keeper, and we will in the zone keeper we will store the mapping from which which shard has the which character like A or D, etc. So we will know correctly like which shard we should route the request to. Cassandra, auto-scalable, ETL job, batch jobs. We actually can here for the batch job we can roll out. So like for example, we don't need to store every hour. I mean, for the Cassandra table we have the hour interval, right? We can aggregate even further. For example, we only store the latest hour, 1 hour data. Oh, do we need that? No, actually we just have the order result here. The time interval could be like, oh, data till now, right? Lifetime till now. That's the batch job. And we have the streaming. And the streaming will have the latest maybe 1 hour, etc. HDFS files raw data could partition based on the hour, the time. Even the consumer auto-scalable filtering. Actually, there shouldn't be a lot of words. It could be like a megabyte, and it may just be a cache here in the middle. So we'll have a cache. It could be the cache in the pod. It could be a cache in distributed data store like Redis. So we have a cache. And then if we cannot get the data in the cache, oh, here we go. Then we will query the filtering service. Cool. Streaming, same. Yep. Okay, so hit the cache first and then the filtering. The UI, yeah, that's it. That's the autocomplete system. We can talk, we can quickly cover the requirements. Search service, yes. English all the letters or lowercase, yes. And top 10 results frequency, yes. Will not consider common shared search trends for all user search history, yes. So if we want to support the user's personalization or the user search history for each user, we will have its own data, right? We actually can cover that in our streaming job. For example, for the streaming job, we may have that user and the top searched word for that user for that 10 minutes or time period. And in our Cassandra table, that's like real time. And for the Cassandra table, we may also track that, but it will be a lot of data. So we may not track the top 10. We track like maybe top 3, just 3 words for that user. So for each user, besides the common shared try tree, we may have user specific like strings or try tree, but only for like 3 words, right? Not much. The other thing is the real-time hot train words. So the streaming job. So streaming job may query. We may have so this is a batch job. We may have a different service, or we may after the event consumer consume the event. Besides it output all the raw data to HDFS, we may have a service called like just the hot. What's going on right now, like the hot search train, and then it will output to that, and then the streaming job will digest that from hot and then right to the try tree, right? What else? We want to performance low latency. Yeah, it's just a Redis lookup. It should be very fast. Fault tolerance. So yeah, every part, if error out, you will still have other results. For example, the radius, we have the primary, secondary, so the data is replicated. Scaling, yeah, so every part can be auto scaled. Efficiency, I think this is quite efficient. You can definitely revisit some part if not. So that's the design. Okay, thanks everyone for watching.